Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Hilmi Mujahid bin Ismail Sahimi, and I am a team leader for this project, which is responsible for guiding my group members as we complete for this project. And also, I ensure that I reach my goal for this project by delegating tasks to my team's member and including myself. I'm also responsible to identify the scope of the testing required for a particular release based on the requirements of the document. And then I put out the test plan after discussion with the test team and have it reviewed and approved by the management or development team. I also schedule the test for execution, and then I monitor, measure, control, and report on the test progress, the product quality status, and the test results, adapting the test plan, and compensating as needed to adjust to evolving conditions. During the test execution, I write the summary reports on the test status.
Now, I'm gonna talk about design engineer. In general, design engineers study, research, and develop ideas for new product and the system used to make them. They do research and draft the blueprints, engineering plans, graphic, and develop the test prototypes. Their work scope also require them to identify solutions to improve production efficiency and at the same time assessing all engineering prototypes to determine any issues or risks. Design engineer also supervise the manufacturing process of all designs and coordinate with other engineers, management, and the creative department. In this project, the design engineer design and develop logic to support the FT architecture and RTL design, such as Verilog.
Now I will discuss about the roles of DFT engineer. DFT stands for Design for Testability. DFT engineer need to develop and implement of DFT architecture. DFT consists of IC design technique that add testability feature to a hardware product design. DFT engineer play an important roles in the development of test program and as an interface for test application and diagnosis. That means DFT engineer will design and verify the DFT logic and component. Moreover, ATPG or automatic test pattern generation is much easier if appropriate DFT rules and suggestions have been implemented and can generate the high quality tests and debug pattern.
Here is the project Gantt chart. In the early stage, a research on each important role in this project has been made, followed by the Gantt chart and milestone completion. In week 10, project flow has been in progress until week 11, followed by the brainstorming among the group for the decision making of the suitable mode that are going to be used for this project. At the same time, the target test and fault coverage has also been determined. At the remainder of week 11, project planning is presented and it will be further proceed for the project implementation. Now, we're gonna talk about project milestone. Project milestone is quite similar to the Gantt chart, except it is more to measure achievement in the project flow instead of listing down all the process like in the Gantt chart. As you can see from the figure shown, we start all this process in week 9. And by the end of week 10, the project flowchart has been completed and the decision making on the suitable mode for this project has been achieved. The project planning is then presented in week 11. RTL design, synthesis, netlist, and scan insertion will be made during the process implementation phase with the expected date of presentation in week 13. After all this project has been complete, the final report will then be submitted in week 14.
The flow of this project is start with the company that is interested in receiving this project from the client according to his request. Then 3 engineers are assigned by the manager to complete this project. These 3 engineers are divided into their respective roles and need to perform their tasks in the timeline that has been set accordingly to project planning. The RTL design that has been given will go through a simulation process conducted by a design engineer. If the design functions correctly on simulation without any error, the RTL design is valid and will move on the next process. If there is a problem in the process, we'll repeat to the RTL design to solve the problem that arises. Next, the synthesis process carry out. In this process, the design was transformed into the netlist form. This process will also go through simulation, and if there is a problem or error, it will return to the previous process. After that, the complete synthesis process will go through the scan insertion process, which determines the test scan method on the design. But before that, the FT engineer has to decide on the selection of the appropriate scan mode according to the client request. Results of 2 different scan modes that can be used for a given design, which is a bypass or compress mode. The usage of the scan compression is mandatory in order to significantly reduce the test time, as a client requests to complete this project within 3 weeks. If this process not complete according to the client request, then it will start again in the RTL design process. Result and output from the entire complete process will then be reported to the client within 2 weeks.
For this project, our group used test compression mode. Why? Because for testing time, it can take shorter time since shift in and out process was designed as multiple scan chain. Shorter scan chain required less test time to shift in the test pattern when scan enable is high, but testing cost still be high as need more pin to drive the ATPC pattern into the design test, and there are many scan pattern per chip. The most important of using test compression technique using test pattern that was test compress was when the ATPG pattern compress, the last pin can compress to only one ADT in and out pin. Furthermore, in the design, there is a built-in decompressor block which can decompress the ATPC pattern and the demarks to the parallel scan chain. Okay, the parallel scan chain scan out will go through a built-in design of a compressor to compress the parallel scan chain into the compressed ADT out pin. The EDT out pin is a output from the chip and compared by the tester with the expected compressed ATPG pattern for matching. For test and fault coverage value that had been used in previous lab session was 10 and 12 scan chain. The difference between two value scan chain was the higher the value scan chain, the lower the value scan cell for one chain. Okay, for 12 scan chain we get value of 48. For one scan cell, then times by 12 scan chain, the total value scan chain was 576. There was not much different percentage value for test and fault coverage. For example, for test coverage was 99.97% and for fault coverage was 98.16%. Fault coverage defined as the number of fault detected divided by the number of potential fault, and chain test value is targeted on fault in scan chain, scan cell, clock signal, and SE signal.
This project targeted test coverage is 99.5%, while the targeted fault coverage is 98.5%.